Alright, so we're going to be analyzing key features of a graph. We're going to start with domain, which is all of our x values. We want to go from left to right. So here on our graph, we have an x value of -4. But notice this is a colored in circle. That means that this point is included in the graph. So my lowest x value that is graphed is -4. And that is included, so that gets the bracket. The bracket is what indicates that the endpoint is included. So a bracket because it's included. And then as I go across, my greatest x value is here at +1, 2, 3. But here I have an open circle. An open circle is not included, or we could say excluded. And so my domain is going to go to 3, but that's going to have a parentheses because it goes up to 3, but it doesn't include 3. So that's saying it goes to 2.9999999999999 and keep going. But it does not touch the 3. Alright, interval notation is the one that we're going to use the most. That's why I put it on top. But you do at least have to be familiar with the other two notations. So inequality notation, I like to put the x down first in the middle. And then I'm going to use my interval notation to help me graph. X has to be greater than or equal, the bracket here will correspond to an equals there, -4. And then x has to be less than 3. No equals there because the 3 is not included. Alright, then we have our set notation, which is a brace. Then I put an x with a little vertical line, and that means such that x is an element of the real numbers, r. And then we put our inequality notation right in that spot. So -4, less than or equal to x, less than 3, and then we end with a brace. And that is set notation. Alright, when we go to look at the range of a function, the range is all of our y values. And your eyeballs want to start down and go up. So you want to start down and go up when you're looking at your range. So if I come here, my lowest point is at -1, -2, -3, right there. So for interval notation, I'll go -3, and I'm putting a bracket because that point has a colored in circle. And then I'm going to go up to my highest point for y, which is here, which I look over. That's about 1, 2, 3.5. And 3.5, that point that is on the graph. So that will go to 3.5 with a bracket. So now both endpoints are included for the range. So for my inequality notation, y is going to go in the middle. Y is greater than or equal to -3. Y is less than or equal to 3.5. Then for set notation, we make a brace. Y such that y is an element of the real numbers. And then we just put our inequality notation. -3, less than or equal to y, less than or equal to 3.5, and a brace at the end. So the other key feature we want to talk about with this graph is maximums and minimums. We want to distinguish between absolute max and min and relative max and min. So the absolute, that's the max or min of the whole entire graph. So when this question here asks me for the absolute maximum value, that's asking me for the highest point on the graph. It's going to be this point right here. And the value means the output, so it's the Y answer. So my absolute maximum value is 3.5. Now this next question asks, when does the maximum occur? It doesn't mean when, like 11:13 a.m. It's not a time question. When does the maximum occur? It's asking at what X value, at what input do you get an output of 3.5? So that looks to be about negative 1.5. All right, the next question is talking about an absolute minimum. And it says, what are the coordinates of the absolute minimum? So first let's look on the graph and find the absolute minimum. It's going to be this point right here. This is my absolute minimum. And so when it asks for the coordinates, then I'm going to give the ordered pair, -4, -3. So here's something that is confusing sometimes in math. This is an ordered pair, not an interval, right? So this is the point that is the absolute minimum. Whereas over here we had things that kind of looked like ordered pairs, but they were actually intervals. It's one of those things where math is not extremely specific. All right, now let's talk about this next word, the coordinates of the relative minimum. What that means is there a spot? Some graphs have a relative min or a relative max, and some graphs don't. But is there a spot where that point on the graph is the lowest compared to the points on either side of it? So there is a relative minimum here. So it's not the absolute minimum because it's not the lowest point on the graph, but it's the lowest point around. So if I only looked on a certain interval, then that would be the minimum for that section. So my relative minimum is at the point 2, and then I'm going to call that negative 0.25, maybe negative 1/4. I'm estimating there. All right, let's take a quick pause. Turn to your partner. Talk about domain, range. What's the difference between the absolute minimum and the relative minimum? Turn and talk. There can be more than one, yes. All right, so for the second graph, I want you to go ahead and figure out the domain and range and write those down, and then we'll do the others together. But you go ahead and look at that second graph. You should be able to do domain and range. All right, turn and talk with your partner just about the domain and range of the next graph.
Yeah, but it's down to us. So you do no negative or
All right, so on our second graph, we want to look for the domain, and it says in interval notation. So if we go left, the leftmost point, -6. And again, you're going to assume that that's touching the 6, unless there's actually, you can see an open circle. So -6 is going to be included, and we're going to go all the way across to +4. So that's going to be in brackets, -6 to 4. That's your domain. For our range, we start at the bottom. So we're going to go from -4 all the way up to +3. And those would also be in brackets. All right, now we're going to talk max and min. We're going to start with the absolute maximum and the absolute minimum. So, absolute maximum, highest point on the graph, right here. This is our absolute maximum. So we want that ordered pair. So that's going to be -6, 3. All right, next question asks for coordinates of the absolute minimum. So the lowest point on the whole graph, right here. This is your absolute minimum. So we're going to give that ordered pair. That's 3, -4. Okay, then we're going to look for a relative maximum. So this graph, unlike the other graph didn't have a relative maximum, but this one has a relative maximum at this point here. Relative max. It's the highest point in that area. So if I don't look here and I don't look here, now that's the highest point. And so that's going to be at 1, 0. And then this graph also has a relative minimum, which is going to be this point here. So this is the lowest point relative to the surrounding points. And so the coordinates of the relative minimum are going to be at 0, -2. All right, talk with your partner about max and min, difference between absolute and relative. How are you going to know where they are? Talk.
Could this be the relative maximum?
Well, it's an what be a relative? No, that's going to be an absolute maximum.
So the absolute can't be a relative. It's higher than like the
Yeah, but it's like absolute is like being better than relative. So. All right. So now we're going to talk about the last idea. Okay, so now we're going to talk about when a function is increasing or decreasing. So this goes back to your slope. So when your slope is positive, like this, you're increasing. And then when your slope is negative, you're decreasing. Okay? But when it says on what interval, what you need to understand is we're measuring this interval on the x. Alright, so here's how I'm going to come and look at that. I want to go see where the function is increasing. So I've got a positive slope. So do you see that right here? This is increasing. So then I want the x values for here. So that is x going from 0 to 1. So my interval is the interval 0 to 1. These are x values. Alright, well notice there was an s, because there's another interval that's increasing. So my function is also increasing here. So that's the spot of the function I'm looking at to be increasing. But what are those x values? Come up to your x-axis and look at where they are. That's between 3 and 4. So these are not ordered pairs. These are intervals. X is between 0 and 1. X is between 3 and 4. Alright, so now I want the intervals that it's decreasing. So if I go to my graph, here's a very long stretch that's all decreasing. But what are those x values? From -6 all the way up to 0. So when it says on what interval is the function decreasing, that's going to be -6 to 0. Then there's another spot that's decreasing, which is here. And that's x going from 1 to 3. Alright, these last questions are about evaluating. This is just kind of a review from what we did the other day. So, f of 4. So when your input is 4, what's your output? So look on your graph for an input of 4, and then read off the output. What is it, guys? -3. When your input is -5, so -5 on x, what is your output? 2. Now, notice this is a different question. F of x equals -2. The output is -2. The y value is -2. What x gives you a y value of -2? 0 is one answer. And what's the other answer? 2. So you have to be sure that if there's more than one spot that you get them both. Alright, guys, as you pack up, I have your conics test for you. And I wanted you to have them before the weekend because, guys, if we'll talk about reassessing next week, but if you do not have a good grade, you want to start by backtracking. Make sure you've got all the IXLs that are related to this done. All right, Jaden, hand you this. Guys, if you have not taken this test yet, I think I've talked to most of you individually, but you need to get that done. Julia, Jesse. Kenta. Normally that would be a yes, but tomorrow I have to do all that.
Okay.
So, you can wait. I'm all right, you were out.
Yeah.
I felt you so much. Okay, so first. Oh, I'm scared. Oh, that's not bad. 86. Oh, gosh, darn it. I forgot to put square. That is so annoying.